Free time to do your homework. Okay, so ready. So indefinite integrals and the net change theorem. So when an integral has those numbers on the end, those are called the bounds. And something that looks like this, integral from a to b, f of x dx, this is called a definite integral. And its meaning is the area under y equals f of x from x equals a to x equals b. And finding that area involves the process of taking an antiderivative, right? You take an antiderivative, you plug in b, you plug in a, right? If you take the bounds off, that is called an indefinite integral. And that symbol means find the antiderivative. Just like the prime symbol means take the derivative, right? So this means find an antiderivative of f of x. And in that case, really an isn't quite right. It really is the most general. So in essence, this section really is section 4.9 over again. Because what you're going to be doing is you're going to be asked to find a bunch of antiderivatives. And because they're general ones, you do, in this case, have to put plus c. So the indefinite ones, plus c needed. The definite integrals, no need for plus c. If you put it there, you're not going to be wrong. But often what I've found is when students put plus c with the definite integrals, they freak out when the c's cancel, and then they put the c back in at the end. So that's what I've seen. People losing their minds. Okay, so verify by differentiation that this is correct. So this thing means find an antiderivative of x cosine x. So of that function. And somebody who knows a little bit more math than you do, like I could figure this one out, it's something called integration by parts. That's section 7.1 in your textbook. How would you check, and even if you don't know how to do that, how could you check and see if they're right? Take the derivative of x sine x plus cosine x plus c. And if you do, if they are correct, you should get back x cosine x. That's how you verify it. And since this is really, you have to actually show your work here, because otherwise you know you should get x cosine x, right? So what rule is required to differentiate that first part? The product rule. So that will be 1 times, I hate when I do that. 1 times sine, right? Go away. 1 times sine x plus x cosine x. Yep. So that's the derivative of the x sine x. What's the derivative of the cosine x part? Oh, lovely. Plus 0, right? Now what happens to the sines? They cancel, and we get, we just get x cosine x, which is what we're supposed to get in the first place, right? So that's verifying that this is the correct formula. And you could use that process to, at least on most of the stuff you're going to do in this class, just check your answers. That's how I do it. I antidifferentiate cosine by saying, okay, I think it's sine. And then I check by differentiation, did I get the plus or minus correct? That's my thought process. Okay, so this thing means that capital F prime of x equals f of x. That symbol means find an antiderivative. Does that make sense? So find antiderivative of little f. That's what it's telling you to do. And really, actually, it's kind of hard for people like me to teach section 4.9 and not use that symbol, because like there should be a symbol that says do this operation, and that's what it is. Some textbooks do introduce that symbol earlier, and as a result you do use it right away, but this book doesn't. Okay, so things you should already know. So first thing is that constants can factor out of the anti-differentiation process. That's totally fine. I missed my dx here. I shouldn't have done that. Bad teacher. It's legit to, when you're integrating a sum or difference, to integrate the first term plus or minus, integrate the second term. That's totally fine. You break it into two pieces. So those are kind of just general guidelines for things you can do as opposed to specific rules about specific functions. What's the antiderivative of x to the n? It's that reverse power rule. 1 over n plus 1, x to the n plus 1. And then this would have a plus c on it because it's a general antiderivative. And there's one slight problem. N cannot equal -1. And the reason that formula fails for n equals -1 is that coefficient becomes 1 over 0, right? Now the rule for n equals -1 actually is this rule. Because 1 over x is the same thing as x to the -1, isn't it? What's the antiderivative of 1 over x? Ln x. You technically need absolute value bars there, and that's because the 1 over x function has two branches. And also the derivative of ln of absolute value x was just 1 over x. We proved that. I know it was like a long time ago, but we did show it. Okay.
Well, it has two branches, but you also can take down a negative number, right?
Now you can when you put absolute value bars there, though.
Yeah.
Yeah.
That's why.
It also isn't obvious that an absolute value derivative would be 1 over x without the bars there at all, but it is the case that that's true. So antiderivative of sine, is it cosine? It'd be negative cosine. How about antiderivative of cosine? Just plain old sine. Tangent, Cosecant squared. Almost. Negative. Because cotangent's derivative is negative cosecant squared. So to get that negative canceling out, you'd have to have another negative there. Okay, how about secant tan? Secant. How about cosecant cotangent? Negative cosecant, yep. E to the x is your fave. E to the x. A to the x probably is your least favorite. It's a to the x over ln of a. Spectacular. And then the last two. Inverse sine. You could also say negative inverse cosine, okay, but almost no one does. How about this one? Arctan.
Is there any case where you would need to say negative inverse cosine?
No, that's why almost no one does. So sine inverse is simpler in that it has no negative with it. So but it wouldn't be, a couple of you in your test did say inverse cosine. I thought you were wrong for a second until I was like, oh yeah, that's right, it still works that way. So I think I caught myself before I counted you off. Okay, so find an antiderivative of these things. In this case, there's no need to plug numbers in, but you do need plus c. So what's the antiderivative of 10x to the 4th? I would say 10 over 5, x to the 5, which is 2x to the 5th. And then how about the secant squared? 10x, and then plus c. So 2x to the 5th minus 2 tan x plus c. You add the c because you're not doing the bounds, and then that symbol just means find an antiderivative. And if the most general one would include plus c. Okay, still no product rule. There's really still no product rule, so first multiply. So you get the integral of x plus 2x to the 5th plus 1 plus 2x to the 4th. Wait, I didn't antidifferentiate yet. But I just did, x times both things, 1 times both things. At first I was distributing because there is no product rule, so we're not going to apply that because it's wrong. Oh, you thought there was an x where the 1 is?
Yeah.
It just bothers me when the things are not highest to lowest power, so I'm going to rearrange them because I'm OCD like that. 2x to the 5th plus 2x to the 4th. Does it bother anybody else?
It's weird.
It's weird. It's not actually wrong because addition is commutative and you can change the order, but it just feels strange. Okay, so now that things are arranged correctly and everything's in order, what's the antiderivative of 2x to the 5th?
1/3 x to the 6th.
Mm-hmm.
2/5 x to the 6th.
Yep. Plus 1/2 x squared
X.
plus x plus c. Yay. Not hard, right? Okay. Ooh. So, no quotient really. So your only option is to try to change this into trig functions you know something about. So here's the hint. Make it into cosine theta over sine theta times 1 over sine theta, which becomes cotangent theta times cosecant theta. And you should be able to manipulate that integral into something you know the antiderivative of, at least at this stage, okay? There's another way to do this from section 5.5, which we'll learn tomorrow. But for now, this is the only way that's going to work for you. So mess with it until you get one of those trig functions you have an antidifferentiation formula for. And the antiderivative of that is just negative,
Cosine squared.
just cosecant, no squared. And really, in the case of these antiderivatives, there are no hard and fast rules. There's just kind of trickery and messing with stuff and making it look like things that you know. So I'm not like withholding anything from you. It's just, there's no hard, it's kind of like with factoring. There's no great way to go backwards all the time, right? Oops, that was not meant to do that one. Well, fractions don't break up. Here's my hint. That becomes cosine x over sine squared x, right? Which makes it into the first one, doesn't it? Which is the same thing as cosine x over sine, 1 over sine, or cotangent x, cosecant x. So here you go. Yeah, tricky. The tricky thing is that when you do trig, they tell you where to take that identity to. They say, okay, prove this equals this. But with this one, you've got to figure out, what am I trying to make this equal to? And what you're trying to make these things look like are things that are in your list of antidifferentiation formulas. But that's tricky. All right. What's the antiderivative of x to the 5th? Great. What's the antiderivative of 5 to the x? Do you guys agree? 5 to the x over natural log 5? Antiderivative of 1 is just x, and don't forget your plus c. Okay. All right. Antiderivative of x. And the antiderivative of 1, x. How about, okay, and 2 times inverse tangent. Very good. Plus c. On your test, there was a question a bit like this because you also had antiderivatives on there. Why not 2 ln of x squared plus 1? Why? Because you see denominator, you think, oh, maybe it solves a natural log. Yeah, so if this was equal to y, then the derivative of that would be 2 over x squared plus 1 times another 2x, right? And this does not have a 2x in the numerator. So that's the reason it's not natural log of x squared plus 1. Does that make sense? Okay. Oh, still no product rule, still no chain rule, so your only option is to distribute. So this really is 3 minus x times 3 minus x over x squared. Does that make sense? Because both the numerator and denominator square. When you expand out that numerator, what do we get? Do you guys agree? Okay. Can I make it times x to the negative 2 in that step then as well? Because then I'll distribute and I'll do the whole adding powers business. So that becomes 9x to the negative second, right? Minus 6x, what's the new power? And then plus 1. Can you reverse power rule the first term? That'll be 9x to the negative first over negative 1, right? Or negative 9 over x. Yep, if you want to say that right away, that's totally fine. This next part really is negative 6 over x, right? So minus 6 natural log absolute value of x, right? Minus 6 ln absolute value of x. And lastly, you have plus x, right? And then plus c. I'm almost positive there was a question a little bit like that on your test. It didn't have you expand, but it probably had you start at like this step and then do the antidifferentiation. Is that okay? All right, C. X over 7 versus 7 over x. So let's think about this as 1/7 times x minus 7 times 1 over x. Do you guys agree that that's the same thing? The second one is natural log x, and the first one is minus 7 ln absolute value x plus c. It's like Natalie said, 1 over 14x squared minus 7 natural log absolute value of x plus c. Does that make sense? Oh, so similar and then yet so different. Okay. Remember how we had that question where the root 2, so these are also, now all of a sudden these are definite, right? Do we need the plus c's now? No. Now that root 2, that 2 is inside the square root thing, and you can't apply the reverse product rule until you've taken the 2 out. So there was that question we had where the 2 was in the numerator of a fraction. This is quite similar. You have to first break this into root 2 times root x. You can't do your antiderivative rule until you just have x to a power. You can't have 2x to a power, because that would involve some kind of chain rule thing that you don't have yet. So that becomes root 2. What's the antiderivative of x to the 1/2? 2x to the, oh no, that's wrong, it's not 2x to the, 2/3, yes. X to the 3/2, from 0 to 9. So 2 root 2 over 3 times 9 to the 3/2 minus 0. What does 9 to the 3/2 work out to be? You root 9, you get 3 cubed is 27. So I think that's 2 root 2 times 9, or what? 18 root 2. But kicker is, has to just be x to a power. That's the really important thing in that question. Does that make sense? Okay. Oh, still no product rule, guys. There's still no product rule. Okay. So your option, what you have to do here is you have to distribute, right? And before distribution, I would rewrite those powers as ratios. So what is the first power? X to the 5 over 4. The next one is x to the 1 over 5. I didn't distribute yet. If you distributed, then it would be 6 over 5. Is that what you said, Rachel? Yeah, okay. Now distribute. When you do x times x to the 5 quarters, so 4 quarters plus 5 quarters is 9 quarters. And then x to the 6/5. Did you get better at adding fractions in your head this semester? Yeah, crazy, huh? Who would have thought? I mean, I would have thought. I believed in you. What's the antiderivative of x to the 9 quarters? 9 quarters plus. So 13 over 4, and then 4/13, I think, right? X to the 11 over 5, and then, 0 to 1. And thank goodness I picked small numbers, right? As in like, that would have been awful otherwise. So it's 4/13 plus 5/11. Oh goodness. 44 over 13 times 11. Here's how I'd do it. I'd make it 13 times 10 plus 1. That's the trick I didn't get in high school, in like elementary school. My friends could all do stuff fast, and I was like, how are they doing that? And I just didn't understand. 130 plus 13, right? I think what you're technically doing then is 110 plus 3 times 10 plus 1. You're kind of doing like FOIL. Yep, that works too. But 143 in any case, right? And this times 13 over 13. So what's that, 50 plus?
No.
I think it's 65, right? Because it's 50 plus 15. Yeah, 143. So I believe that's 109 over 143. Is that right? Okay. Awesome. Do you guys know the rule for checking for divisibility by 3? Checking for divisibility by 2 is really easy, right? Because if the numbers are both even, it's divisible by 2. To be divisible by 3, if you add the digits and the result is divisible by 3, then your number is divisible by 3. It's like the numerator, 1 plus 0 plus 9 is 10. 3 doesn't go into 10. It doesn't go into that 109 either.
But 143.
143, 8. 3 won't go into that either. And that works even if you like repeat the process. Like if the number you get is still too big and you don't know, you do it again, it will work.
That's pretty cool.
It's a really cool trick, and I at one point in time knew how to prove it, and I think if I sat down I could figure it out again, but it's a really neat trick. And it also works for, kind of works for 6, because if it's even and you can do that trick, 2 and 3 go into it, so it's 6. It's pretty fun. I mean, anyway, it's a good trick that is kind of lost a little bit now. Oh man. Okay, this one. So first of all, since we do have a fraction, we should probably check, like, is this function continuous on our interval? But, so yes, so we're good to go. Do you want to bring the power up and distribute? No? Or you could just divide. Does that make sense? You can divide every piece by t squared, can't you?
Yeah.
So this becomes the integral from 1 to 9, 2, right? Plus root t. And then minus t to the negative 2. Does that make sense? It's the same result if you make it t to the negative 2 and distribute and add powers. This is just dividing everything so you subtract powers.
I'm just subtracting.
Exactly. So what's the antiderivative of 2? 2t, right? How about t to the 1/2? 1/2 plus 1 is 3/2. And then coefficient 2/3, right? And then minus, that'll be t to the -1 over -1. So can I just say plus? Okay. The arithmetic here might get ugly. So that will be 18 plus 2/3 times, how about we just do 9 to the 3/2 right away? 27, okay. And then plus a 9th, does that make sense? And then minus 2 plus 2/3 plus 1, because 1 over 1 is just 1, right? Wait, arithmetic. 18 plus 50, well, it's 27 divided by 3 is 9. It's easier to do that, right? And then 9 times 2 is 18. It's easier to make the number smaller before making it bigger, right? And general division does that. Well, minus 3 and minus 2/3. Do you agree? So the whole numbers, when added up, 33. And then I've got plus a 9th minus 2/3. So unfortunately, the common denominator is going to be 9. So I think 270 plus 27. Do you guys agree? That's not the only best way to do it, but 297 ninths plus a 9th minus 18 ninths. And actually, you can think about that as 297 over 9 minus 17 ninths, which is even easier to subtract, right? Because you can combine. Say that again? 280, yeah, you were just giving me the answer, sorry. Oh, shoot, oh, it was so nice, never mind. Okay, yep, thank you. That should have been 3 over 3, which would have made this 6 over 9. So that would be minus how many ninths? 5, right? Sorry, guys. So I think,
292?
Does 3 go into the numerator? No. Did I get that? Is that better? Yeah? Is that what you got? Okay, good. Arithmetic. If you make mistakes in these, like WebAssign tells you you're wrong, it's probably the adding. Okay, great. Divide each term by sine squared. Does that make sense? So the 1 over sine squared will be cosecant squared. And let's just think. So sine looks like, I wonder if I made a problem that actually, no, that's okay, because there's pi halves, right? So you'd be checking, is this sine ever 0 within that interval? And the first place sine is 0 is at 0, but the next place is at pi, right? So as long as your numbers are between 0 and pi, you're okay. That denominator isn't 0. So what's the antiderivative of cosecant squared? Yeah.
I might remember that. Can we just make it cotangent squared?
Maybe, but you don't have an antidifferentiation formula for cotangent squared. But you're probably right. Like cosecant squared plus 1 is, no, is it? No, I think you might have that mixed up. I think it might be mixed. I think it might be cosecant squared minus 1. That's cotangent squared, I believe. Yep. But you do have an antidifferentiation for do you have one for cosecant squared? I think you do. Yeah, so it's minus cotangent, isn't it? And then the antiderivative of 1 is Well, in this case, it's theta because the variable's theta, but you know. From pi quarters to pi halves.
1 plus cotangent squared of x is equal to cosecant squared of x.
Yeah, that's what I thought. So negative cotangent of pi halves plus pi halves minus negative cotangent of pi quarters plus pi quarters. So what is cotangent of pi halves? You're right, say it loud. I think I heard you say something. You didn't say? Okay, so cotangent is cosine over sine, right? As opposed to sine over cosine, right? So it'd be 0 in this case. I thought I heard you say that. Plus pi halves minus a, is cotangent of pi quarters going to be different than tangent of pi quarters? No, so that will be 1, except for we have that negative sign there because of the fact that we had a negative antiderivative. Plus pi quarters. So we have pi halves plus 1 minus pi quarters. Is that okay?
Pi quarters plus 1.
Which is pi quarters plus 1. And you can just leave it. There's no need to get a common denominator unless I specify to do so. Like you could say pi plus 4 over 4, but it's not necessary. Is that all right? Oh, if I do a half pi minus a quarter pi, I get a quarter pi.
Pi sounds good.
Pi does sound good. If I had half pi and I gave you a quarter of it, then I still have a quarter for myself. Woo! Yay, pi. Okay, so the last thing we have in this section is something called the net change theorem. So the integral of a rate of change is something called the net change. So, for example, if I have, so suppose this is my A and this is my B, and this is in seconds, and this unit is in meters per second. And suppose this is the graph of capital F prime of x. So if I were to add up all of these areas, this area down below the x-axis has the effect of canceling out some of the other areas, right? So what this is saying is that this will, the area under this curve will tell me the meters, as will be its units, but it will tell me how much my meters have changed, as opposed to how much distance I've traveled. Because in order to say distance traveled, this is kind of like the particle goes forwards, it goes backwards, right? And then it goes forwards again, right? So it tells you what the overall change is, but not if there was any kind of like back and forth in the middle. Yeah, so it's different. It's kind of like those questions that we had where we were kind of graphing the position of the particle. It's different than like the last, it's different finding the total. This tells, this kind of, the integral sort of cancels out some things that maybe undo each other. Whereas if you wanted to find out, like in this instance, this is called the displacement in this case versus distance traveled, which is something different. You'd have to make this area into a positive and then account for it that way.
So this counts for everything together?
Yeah, this accounts,
It does
puts,
totally
it puts some
stuff.
stuff together. Yep, definitely. Okay. All right, so if the oil leaks from a tank at a rate of R of T gallons per minute, is it fair to assume that the rate at which the stuff is leaking is probably positive? Yeah, okay. So then what does this integral represent? So think about this. You have an R of T function that's doing something and it's positive. And the Y is measured in gallons per minute. And this axis is measured in minutes. And this is from, so it tells you how much oil leaked out between 60 and 180 minutes. So it tells you how much oil leaked out in gallons from T equals 60 to T equals 180. And I specified something similar, like when there was, gosh, this was a while ago, but there was an oil spill in the Gulf, right? And now it was like 5 years ago, wasn't it? They probably knew the rate at which the oil was coming out. They probably could measure that, right? And then they could use an integral to estimate how much oil had leaked in the first place. Okay. So a honeybee population begins with 100 bees, and it increases at this rate, so that many bees per week. And that rate accounts for the fact that some bees die and some bees are born, or hatch, however bees are born. So this part tells you, and think about the units. This would be in the top, this unit would be weeks. This would be bees per week. What would the area under the curve be? It'd be how many bees, how many new bees, right? So you have the 100 original plus the new bees. 2t equals 15, right? So this is the population.
So we're assuming the bees are immortal?
No, the n prime of t, your rate of growth can actually be births minus deaths. And so since that's positive, it means that there are more births than the deaths.
Oh.
So the n prime accounts for the fact that there are some bees possibly dying. Does that make sense?
Yeah.
Okay. This is the population at 15 weeks. Does that make sense? Versus, okay, so versus, one thing to point out, if I just asked you for this, would that be the population at 15 weeks anymore? It would actually be how many bees were added during the 15 weeks. Because this 100 counts for the how much you have to start with, versus this thing just tells you, without the 100 plus, just tells you how much it's changed. Just like that last question didn't tell you the total amount of oil leak. I told you, like, you know, that there was how much between these two times. Okay. So suppose that W prime of t is the rate of growth of a child in pounds per year. What does this represent? So think about this. This would be the W of 5 minus W of 0, wouldn't it, if you did the antiderivative? Does that make sense? And W, if W prime is the rate of growth, this tells you the child's weight at 5 minus the weight at 0. So this tells you the child has done how much?
How much gain?
Hopefully how much gain, yeah. How much weight?
Can it ever become a negative number?
I don't think that child would be alive.
No, what I mean,
But it could though, yes.
as far as the math part of it.
Yes. So suppose we'd done me and we'd done the integral from, I don't know, 20 to 31, W prime of t dt, which would be W of 31 minus W of 20. If that came out to be, say, like negative 15, what does that mean happened to me between the ages of 20 and 31? I've lost 15 pounds, right? I mean, that's what that would, so it could be negative if the numbers are proper, but I think in the instance from 0 to 5, if you're a baby and you weigh less when you're 5 years old, something is seriously wrong with you. I don't think you can be a fat enough baby for that to actually happen. Does that make sense? But for an adult, that makes sense. Like it's possible that you could have that weight change being negative. It doesn't mean there wasn't some oscillation in there, right? Because my weight could have gone up and gone down, which it definitely did. But overall, that's the change.
Could it happen, you're looking at the wrong interval and what you're seeing is just junk data?
That's possible, but I think, this is certainly possible. Okay, And so these definite integrals mean areas under curves. That's what I want you to get with this next example. So if your x-axis is measured in meters, and your your y-axis is measured in newtons, and you have whatever, so integral from 0 to 100, what are the units for that integral? I mean, the units multiply, right? So they are Newton meters. Weird as it is, whatever that unit means, but because this thing means area under curve, and x's units are that, and y's units are that, the way that you say multiplied in like physics and stuff is with a dash. Does that make sense? Okay. So if the units for x are in feet, and a of x are pounds per foot, so you have feet and pounds per foot. Yeah, so for dA dx, it's pounds per foot, which, as Natalie said, is pounds per square foot. Right? Versus the integral, that units will be pounds per foot times foot, which will be pounds. And just like with derivatives, I think that getting their meaning was easier if you knew what the units were, because that was a really big hint as what you're talking about, right? The same thing is true with antiderivatives. Is looking at what the units mean is quite useful for figuring out what you need to do in the first place. Okay. So the water flows from the bottom of the storage tank at this rate. Why do you think I have this thing ending at, beginning at 0, ending at 250? And what happens at 250, that R is going to be 0, which means your tank is probably empty. Does that make sense? Okay. And it should also make sense that the rate is sort of highest in the beginning because there's more pressure on the water, right? And decreases as time goes on. And so this is in gallons per minute. This is in gallons. How could you figure out how much leaked out during the first hour? So you'd find the integral from 0 to 60. And you can think that the area under the curve will have units gallons, right? So 500 minus 2t dt. And since the time is measured in minutes, you've got to make the one tricky thing here is making sure your t is in the right units. Right? I've said 1 hour on purpose to be a little bit tricky on purpose. But this is not very hard. Can you now do that integral? No problem. 500t minus t squared, right? And 500 times 60 minus 60 squared. So what's 500 times 60? Tell me the number and how many zeros. 3 followed by how many zeros? I think it's 4. Because you do 5 times 6 is 30, and then 3 more. 60 squared is 3,600, 3,600. So 26,400. Do you guys agree with that? How would you check it? What I would do is add 3,600. Does that make sense? Does that add up to be 30,000? Yeah. So another way you could do this subtraction that I think is pretty good is you could do 30,000 minus 3,000 minus a 600, right? And this minus that is 27,000. Right? And take away 600, you have to knock that 7 down to a 6. And then 400. So, and this would be gallons, yes? Big units.
Big tank.
Big tank, yes, big tank. Could be an industrial tank. It could be someplace that has water towers. Okay. All right, so particle moves along the line, so its velocity is this. Find the displacement of the particle during the time period. I'm gonna just tell you how to set this up and tell you what the answer is, because the details for this one are just really ugly. That's not it. That's it. Okay. So the displacement is just what is the change in the particle's position. So how you'll find that is just doing the integral from 1 to 4 of t squared minus t minus 6 dt. That will do position at end minus position at beginning. So that, and this is just a regular antiderivative, 1/3 t cubed minus 1/2 t squared minus 6t from 1 to 4, and after much tedium and lots of stuff, you get negative 4.5 meters. Like, I'll assume given enough time, you can actually do the arithmetic, right? Or I'll try to make the arithmetic easier on a quiz, so you're not bogged down in adding fractions, okay? So what does this mean about the particle's position? What happened? From t equals 1 to, how does the position at time 4 relate to time 1? If this is negative 4.5, the particle is back 4.5 meters from the start at t equals 1. That's the displacement. It's how much from this time to this time has the position changed. So relative to position 1, the particle is 4.5 units backwards from where it was. So the particle could have been someplace like at, 1, and that would be at time t equals 1. So where would it be now at time t equals 4? Negative 3.5 at time 4. You just don't know, did it go like this, right? Did it do like way the heck out there and back? Or did it go straight back, right? You just don't know, right? But relative to where it began, it's 4.5 units backwards. That's what the displacement means, okay? Now, the way to find distance traveled is you've got to account for those little changes. So remember so what does t squared minus t minus 6 look like if we were to graph it? So that'd be t is a parabola, and it'd be t minus 3, t plus 2, right? A factored form. So that parabola has t-intercepts at negative 2 and 3, and it looks like this-ish, right? So this distance, we care about the distance from 3 to 4. And this is in seconds, and this is meters per second. So what did the particle do initially? What does the fact that that area is negative mean happen to the particle? Did it go forward? It went backwards, exactly. And then what happened from time 3 to 4? It goes the other direction, right? So what you have to do is you have to somehow take this stuff and make it positive. So how would you do that? It's a negative, so if it's, you want to make the number into its opposite. So what I mean by that is, could you find the integral from 0 to 3? If you do this, you're going to get a positive or negative number. Negative. To make it positive, stick a negative sign out in front. Right?
You're allowed to do that?
That will make it positive, won't it?
Yeah.
And then plus, you add on the integral from 3 to 4. And that one you just leave alone. And when you do that, the result is 61/6. And that tells you how many spaces the particle has moved, counting forwards and backwards. Like how much has it marched? It's marched backwards a bunch, forwards a bunch. Here's what you're technically doing. You're finding the integral from 0 to 4 of the absolute value. Because what the absolute value does is it takes this picture and it takes that part and makes it go above the axis, right? And then when you find the integral, the area under there is positive, and the area under there is positive. But the only way to find that integral of the absolute value is to break it up into two pieces, like I just did. And you can see that with this, because plugging in those numbers can be really, really super tedious, there's lots of room for error in the addition. So I'll try to make the functions that you do this with pretty simple, like the next one. It'll be more simple. So I'll actually do one where we work out an absolute value integral. Okay, so the acceleration function, I meant to say this was a of t equals 2. So if the acceleration function is this, and the initial velocity is v of 0 is 4, first find the velocity function. So how do you find the velocity function from the acceleration? Antiderivative. So v of t will equal 2t plus c. Don't forget the plus c. C equals -4. So v of t equals 2t minus 4. Oh shoot, I made a boo-boo. I scribbled something else out. Oh, well, whatever, we can still do it this way. Okay. I need to backtrack a sec, because I meant to make this problem harder than I just undid myself. So, x nay, you still got space. Let's leave it as a of t equals 2t. Sorry. I saw a scribble and assumed it meant t when I had +3 that I got rid of. So now what's the antiderivative of 2t? T squared plus c. And is our c still -4? Yeah, so v of t is t squared minus 4. Okay. So there we go. There's the velocity function. Now part B asks us to find the distance traveled from 0 to 3. So to do that, you have to integrate from 0 to 3 the absolute value of your velocity function. That tells you distance. If you leave out the absolute value bars, that tells you what's called the displacement. Like how much the position has changed versus how much has actually moved. So integral from 0 to 3, absolute value of t squared minus 4. And you're always going to break these absolute value integrals into like at least 2 pieces. Hopefully I won't do more than 2 because it just gets too tedious. So you've got to figure out where do you have to break it up. So the way to do that is to graph t squared minus 4. And I should give you a function that's not super hard to graph. T squared minus 4 is a parabola shifted down 4. Where does it cross the t-axis? -2 and 2. Okay. That's what it looks like approximately. So the part that you have to negate is the part that you have to flip over the other axis. So for this one, we care about 0 to 3, right? Which part's already above the t-x axis? The part from 2 to 3. So that part remains unchanged. It's okay. It's already positive. How do you flip the other part over? Make a negative it. Yep. So 0 to, in this case, 2, right? And you do have to work out both of those integrals separately. There's no shortcut. I'm not trying to like withhold stuff from you. It just is what it is. I'm going to send that negative through because I think it'll make it harder to make mistakes. Negative t squared plus 4 dt plus 2 to 3 t squared minus 4. And you can see that it might get kind of gross, right? A little bit. So that will be negative 1/3 t cubed plus 4t evaluated from 0 to 2 plus 1/3 t cubed minus 4t from 2 to 3. And with these, because you're absolute valuing, you should always get a positive answer. If you don't, you've made some mistake. Because if you absolute value correctly, your whole curve should be above the t-axis, right? Which means the area should be positive. It says negative 8/3 plus 8 minus 0, right? That's for the first integral. Plus 27/3 minus 12 minus 8/3 minus 8. Do you agree? Okay. So look, this and this are awfully similar, right? I'm just going to combine like terms there. So I'm going to say negative 16/3 plus 16. Is that okay? And then plus, this actually is 9 minus 12, right? Is that negative 3? Okay. So I've got negative 16/3 plus 13, right? So by 3/3. That would be negative 16/3 plus 39/3 or 23/3. Do you guys agree? That's what I got here. That's the most tedious thing. Like doing those integrals is super tedious. So